All right, in this section, we're going to look at differential equations and how they work and some other kind of cool related items. So the first order of business is to talk about what a differential equation is. And a differential equation is just some sort of equation. It doesn't matter what kind of equation, except that it needs to have a derivative in it. And the order of the differential equation is the order of the highest derivative that's involved. So when you're looking at different things, how can you tell what the order of highest derivative is? Well, it would be something where you would have, like, say, d squared y dx squared. This would be a second order. Or if you were looking at something that said, like, y primed 3 times, okay, that would be a third order. So when we're doing this problem, the problem that we're going to look at today, all we're doing is we're going to look at this guy right here. And he's a first order differential equation. So what do we want to do? We want to solve this guy. And how do you undo derivative? You integrate. So if we multiply, this is kind of neat. If we have this derivative, and you multiply both sides of this equation by dx, then what you end up with is a situation where you have dy equals, the change in y equals all of this stuff, secant x squared plus 2x plus 5 times the change in x. And then if you go one further step and you integrate both sides, okay, so on the left side we're going to have some sort of y variable. On the right side we've got all x variables. Well, if you integrate dy, you're going to get y. So there you go. There's our equation, okay? If we integrate the left-hand side, then what we're wanting to say is the derivative of what thing is secant squared x. Derivative of what is secant squared x. And the derivative of tangent x is secant squared x. The derivative of what is 2x, and that would be derivative of x squared. Okay? The derivative of what is 5, and that would be 5x. And you can check, the great thing about integration is you can take the derivative of all of these things right here and find, and if you can get back to where we started up here in this kind of brownish reddish color, if you can get back to where you started, you've done the right thing. And remember, when you're taking derivative, think about with your trig functions, derivative of what trig function will be secant squared. And you can look at a chart and tell. Or with derivatives, when you take derivative of x, remember you subtract 1 from the exponent. So we know we have to add 1 to the exponent. So those are kind of some tips and tricks to get us started. Well, we want any equation that can satisfy that. So we have to add a constant out here at the end because the derivative of every constant is 0. And to allow for all the possible functions of y that satisfy the equation dy dx equals, then we have to add the c over there. That way we can include every constant that we can think of and we can still get to the correct answer. So there's a differential equation. What it boils down to is integrating both sides.